Large-sized bubbles such as beer bubbles or bubbles from a diffuser plate in an aquarium can be observed. The existence of fine bubbles, tens of micrometers in size, can be confirmed using turbidity, which is caused by light diffusion from bubbles. Innovations in generating systems enable the optimal generation of fine bubbles containing many ultrafine bubbles with sizes smaller than 1 micrometer. Ultrafine bubbles are invisible. However, the existence of ultrafine bubbles can be confirmed by observing trajectories caused by the light scattering from ultrafine bubbles in ultrapure water when irradiated by a green laser. Various methods are being developed for the accurate measuring of the invisible ultrafine bubbles. Practical applications based on fine bubble technologies extend from water purification in the field to various areas of agriculture, forestry, fisheries, manufacturing industries, and medical applications. Meanwhile, these developments and applications can go global as well. They can contribute to the actions of Sustainable Development Goals adopted by the United Nations. Ordinary optical microscopes do not work for the characterization of ultrafine bubbles because their sizes are normally too small to see using the wavelength of visible light. Recently, various new techniques and instruments have been developed to characterize ultrafine bubbles more precisely. To characterize ultrafine bubbles, the laser diffraction method, which measures angular intensity distribution patterns of scattered light from bubbles, and the particle tracking analysis method that analyzes Brownian motion speed in video images of bubbles have been developed. The resonance mass measurement method, the dynamic light scattering method, and other various measurement techniques and instruments have been developed and refined for the characterization of ultrafine bubbles. The fine bubble generation technologies, led by Japanese industries and academia, are developing rapidly. In the pressurized dissolution method, liquid and gas are mixed under high pressure so as to have gas dissolved into the liquid. The quick pressure drop prevents the gas from remaining dissolved and results in ultrafine bubbles. In another method known as the rotary liquid reflux method, gases are broken down into a number of fine bubbles by fast rotary reflux flow, and then the bubbles are separated by flotation. Similarly, various techniques to generate fine bubbles and ultrafine bubbles have been developed. FBIA stands for Fine Bubble Industries Association. It researches practical uses of fine bubbles in Japan. Members of FBIA consist of manufacturers of measuring instruments, generation systems, and products that apply fine bubble technology. FBIA also promotes international standardization and product certification services for fine bubble technology and coordinates development of utilitarian technology with an aim to establish a global market for their products. Furthermore, we conduct research together with universities and national institutes for these technologies. FBIA, established in 2012, continues to expand its domestic and international networks. These activities of FBIA are intended to raise global awareness of the technology and thus to improve competitive markets as well as accelerate the evolution of relevant industries. The United Nations has set 17 SDGs, or Sustainable Development Goals, as targets sought by proposed action plans to solve problems such as poverty, inequality, and climate change. These goals will ensure a bright future. FBIA is promoting research and development based on fine bubble technology as it can be applied to various fields. It is working to achieve the 17 SDGs as well. Fine bubble technology can utilize 5 main effects, including prevention of peeling and redeposition, gas dissolution, gas inclusion, physiological activity, and physical adsorption. Global applications of fine bubble technology are anticipated in various fields. Many practical applications of fine bubble technology have already contributed to bringing about a better international community. As an example of prevention of peeling and redeposition effects in environmental fields, a more efficient cleaning of urinary stalls has been achieved in restrooms with wastewater reuse systems in rest areas along highways. In the field of agriculture and food, a test system for washing ginger by machine using fine bubble technology has been introduced. In the industrial fields of civil engineering and construction, the efficient removal of salt from bridge girders has been highly evaluated. The washing assists highways to function better. In the solar panel and PV wafer equipment field, ultra-fine bubble technology has been introduced to practical use in the wafer separation process for solar cell substrates. Furthermore, fine bubble technology is used for cleaning surface oil on various machines and components. In the field of life science and health, fine bubble technology can reduce environmental loads. For example, the cleaning efficiency of washing machines can be improved using ultra-fine bubble water. In the field of life science and health, the effect of floating separation as physical absorption ensures a cleaner and thus a better living environment. For example, it is used in the automatic cleaning of piping between a water heater and a bath. A desirable cleaning effect can also be achieved in a bath or shower. These examples of applications of fine bubble technology mainly contribute to Goal 6 in the 17 goals of SDGs. Goal 6 is ensure availability and sustainable management of water and sanitation for all. In the gas inclusion application of environmental field research on washing and sterilization technology for oysters is advancing. It is soon expected to reach a level that meets food safety standards. Furthermore, sterilization equipment for medical instruments has been developed, and fine bubble technology in medical care is attracting attention. In the agribusiness and food field, application of new functions of fine bubble technology to foods and beverages has been started. Gas inclusion technology can contribute to Goal 6, ensure availability and sustainable management of water and sanitation for all. For example, this technology can be applied to improve water usage methods, water resource regeneration, and reuse promotion. This will lead to sustainable management of water. Furthermore, in the agribusiness and food field, this technology can contribute to Goal 9, build resilient infrastructure, promote inclusive and sustainable industrialization, and foster innovation. In the agribusiness and food field, the effect of bioactivity can be utilized for agriculture, food, and drinking water. For example, barley germination is promoted. Meanwhile, growth promotion and yield increase for crops such as tomatoes and lettuce have been reported from various countries. By utilizing this technology, it becomes possible to manage forests, halt and reverse land degradation, and promote sustainable agriculture. These applications can contribute to Goal 2, that is, end hunger, achieve food security, improve nutrition, and promote sustainable agriculture. In the agribusiness and food field, the gas dissolution effect can be utilized in the fishery industry. Water quality can be improved by strengthening the functions of septic tanks in order to prevent land degradation. Furthermore, water quality purification systems are being developed to improve pore oxygen in the summer season. In addition, this technology is utilized to remove parasites attached to aquaculture fish, allowing advances in fish farming. These applications can contribute to Goal 14, conserve and sustainably use the ocean, seas, and marine resources. Agriculture is one of the most important industries for Asia-Pacific countries and regions, including the mainland US and Hawaii. FBIA, leading the ISO standardization for application of fine bubbles, together with member countries, has also set up the International Data Sharing Platform for Fine Bubble Applications on Agriculture with Asia-Pacific countries. This is intended to disseminate new sustainable agricultural technology to various corners of the world. This activity goes along with Goal 17, that is, strengthen the means of implementation and revitalize the global partnership for sustainable development. FBIA has contributed to setting up the ISO TC 281 Technical Committee for the standardization of fine bubble technology, based on a proposal made by Japan. International standardization of fine bubble technology is being managed according to a three-layer configuration concept. Basic principle standards such as terminologies and definitions are on the top layer A. Standards for characterization and measurement technology are on the middle layer B. Finally, standards regarding applications for various industrial fields are on the bottom layer C. The first international standard in the ISO TC 281 was published on June 22, 2017. It dealt with the terminology positioning on the A layer and included the definition of microbubbles and ultrafine bubbles. Microbubbles were defined as bubbles smaller than 100 micrometers but larger than 1 micrometer. Ultrafine bubbles were defined as bubbles smaller than 1 micrometer. Dozens of standards for layers B and C are being discussed now and will be published. Both international standardization and the creation of industries and markets through research and development are indispensable. FBIA is pushing ahead the international standardization of fine bubble technology. FBIA has initiated a product certification and registration system to monitor the performance and quality of products applying fine bubble technology. Products with the certification will assure reliability for users. Furthermore, FBIA has established the Forum Standards, defining the measurement method for fine bubbles based on developments in collaboration with NITE. This provides users with a reliable quality evaluation system to be designated in testing laboratories. The product certification and registration system is intended to assure the quality of fine bubble products and services. The Fine Bubble Industries Association, or FBIA, will proceed with international standardization and develop and expand the applications for fine bubble technologies. FBIA contributes to achieving the targets of the Sustainable Development Goals project, which involves more than 190 UN countries.